In this video, we're going to talk about rational function. First, an introduction. So what is a rational function? So a rational function is in the form of, I'm going to use R, stands for rational, and then it contains two polynomial. The one on the top is the numerator polynomial star. I use the letter N to represent the polynomial on the top. And the one that in the bottom I denoted as dx means the polynomial. So the numerator and the denominator are polynomial. So such as y equals to x to the fourth minus 2x plus 1 over 2x squared plus 3x. So these two are two different polynomials. The numerator and denominator combining together is called the rational function. So now the most two basic rational function we have is the reciprocal function y equals to 1 over x. So the graph look like this one. And then the other one is the reciprocal square function, or the square reciprocal function. This one is they both on the top. Okay, so now let's look at the end behavior. Remember what is end behavior? We discussed that in the polynomial chapter. Is as x approaching to the infinity, where did the y go? So let's look at the reciprocal function first. As x approaching to infinity, y goes to 0, right? So we have y goes to 0. Now, if x goes to the negative infinity, y also goes to 0. Really getting approaching to 0. Look, our y originally was here. When they're getting close to the negative infinity, it really going up towards the s-axis, which means the 0, y equals to 0. So similarly, the end behavior of the square reciprocal function, as s approaching to the positive infinity, y also goes to 0. And as x goes to negative infinity, y also goes towards 0. Also getting close and close to 0. Now, let's talk about the local behavior. So the local behavior, usually we refer this as asymptote in rational function. So let's take a look what's the asymptote. So this is the asymptote, the vertical asymptote. That means the function is really approaching to this line, but never touch this line. That's what we call asymptote. Okay, now let's look at the vertical asymptote. So if x coming from the left, approaching, when get close to the asymptote, which is when x equals to 0, y goes to down infinitely. So that means as approaching to 0, y goes to negative infinity. Also, similarly, from the right, as approaching to 0, what happened to y? Y keep going up, so eventually it goes up. So that's the pattern here. So that means as x approaching to 0 from the right, y goes to positive infinity, goes up. So now these two are both goes to 0. One is coming from the left, the other is coming from the right. How can we distinguish that? So in the math, we have a notation to distinguish that. If the 0 is coming from the left, we put a negative on the top. So this is not the power, it's a notation. Tells you that, hey, this is coming from the left. And then if they're coming from the right, we put a positive, meaning that they come in from the right, from the positive side. So similarly, the local behavior for the reciprocal function as x approaching from negative, from the left. So that means coming from here, go, 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 go. It keep going up, right? So that means y approaching to 0. Oh, infinity, positive infinity, because it's keep going up. Up is infinity. So here's the arrow. And then if s coming from the right, which means coming to this side, going to 0, y keep going up, really trying to approach the 0, y is going to infinity. So that means y goes up, positive infinity. So that's the notation. Now, let's do some practice. I want you to use this arrow notation to describe the local behavior and the end behavior. I'm going to use LB stands for local behavior, and the EB means end behavior. Okay, so here is the graph. Y equals to 1x over x minus 2 plus 4. How do we draw this? Well, we can use function transformation. We know that this is come from the basic function y equals to 1 over x, the reciprocal function. Minus 2 means right, move to the right 2 units, and plus 4 gives us a up 4. So combining together, we will have the function look like this. Right 2, so that means the asymptote is going to move to the 2. And then up 4, meaning that the asymptote move into the 4. So here's the asymptote, and this is going to be 4. So that means our function is look like this guy. Okay, now we need to use the arrow notation to describe the end behavior. First, we can describe the local behavior. Local behavior means not the end, not as x approaching to the infinity. So as x approaching to 2, let's take a look. As s really getting close to 2, what happened to y? Y goes down, goes to the down infinity. So that means as x approaching from the left to 2, y goes to negative infinity. As x approaching from the right to 2, which means here, y goes up. So that means y approaching to positive infinity. Now, end behavior. End behavior is when we're looking at when x goes to infinity, to that direction. So as x goes to infinity, positive infinity, y getting very close to 4, and then similarly, as x approaching to the negative infinity, which is x coming to this way, y is getting closer and closer to 4. So y is closing to 4. So in the limit notation, it will look like this way, but you don't need to learn it in this class. I just want to show you the limit, meaning that getting really close to it as x approaching to such as negative 2, our y value, which is the fx function, is approaching to infinity, negative infinity. That's how you denote them. Another one would be the limit of the function as x approaching to positive infinity is equals to 4. So this is just need to get to know. Okay, so that's it for this section. I'll see you next one.